What we're showing here is a 4-point bend setup. There is a bar of plastic in the 4-point bend jig with a notch in it. We're going to use that notch to show the effects of stress concentration. The plastic is photoelastic, and when we put it in polarized light, there will be colors representing the amount of stress exhibited by the material. And so here's the cross polarizers slid into place. And so what you can see is under the loading points there's stress, and then you can even see at the notch that the colors are concentrated. The other thing is this is a bending apparatus, and so what you'll notice in the center is that it will remain pretty much clear, and that's because that's the neutral point, because on the top we're going to have compression and the bottom we're going to have tension. So what we're going to do is we're going to increase the stress, the far field applied stress, and what you'll see is that the stress will be concentrated near the crack tip, or where the notch is. So I'm going to do this side to side, a little bit on each side. And so you notice how the colors increase, but then the distance between bands of color around the notch are smaller and more concentrated. So what we're showing is the stress concentrated around the notch. Now I want to focus in, I want to repeat this experiment, but focus in on the notch. Okay, so now we're showing the notch up close, and you can see that there's kind of this grayish color that representing a relatively small amount of stress. I'm going to increase the stress as before, and you'll be able to see the evolution of the stress concentration adjacent to the notch tip, and how the spacing is a little bit more intense right around the notch tip. And so that's the idea of stress concentration that we'll be continuing to talk about.